Welcome in to Radio-ish EBM, where questions get sharp and answers take shape, one idea at a time. Let's begin.
Right now, somewhere in the world, a baby is taking its very first breath.
Right.
And, if you ask the parents what that child is inheriting from them,
Yeah.
they'll probably talk about, like, eye color.
Or height, yeah.
Exactly. Or maybe, a stubborn streak. But the most crucial inheritance that child receives in that exact moment, well, it isn't encoded in their human DNA.
No, it's really not.
It is the invisible, microscopic ecosystem that's just, waiting for them in the birth canal.
It's a profound shift in how we think about human development, honestly. We're increasingly realizing that this invisible inheritance, this microbial starter pack, a baby, receives functions almost like a second genome.
Oh, wow. A second genome.
Yeah, because it dictates physiological responses that will affect them for the rest of their lives.
And that really brings us to the core of our deep dive today. For you listening, whether you're prepping for a medical meeting or you're just, intensely curious about the hidden machinery of the human body.
Which is fascinating in itself.
Right. This is going to change how you look the very first day of life.
This is Radio EBM.
We're pulling from a pretty comprehensive 2023 qualitative review published in the journal Microbiota and Host.
Very solid paper.
Yeah, it's titled Consequences of a Cesarean Section on the Neonatal Gut Microbiome and Future Outcomes. And our mission today is really twofold. First, we're going to briefly summarize the stark differences in the microbiomes of babies born via C-section versus vaginal delivery.
And second, we'll list the major health risks associated with those specific microbiome differences.
Right, because the researchers who put this together, they were looking at a massive global shift in how humans are born.
They wanted to track the biological echoes of that shift because, altering the mechanics of birth doesn't just change the events of a single day in a hospital room.
Right.
It literally alters a metabolic trajectory.
Okay, let's unpack this. Before we zoom all the way down to look at, bacteria in a newborn's gut, we really need to look at the macro context of childbirth.
Yeah, the big picture.
Exactly. Because historically speaking, the way we give birth has undergone a radical transformation in a very short amount of time.
We really need to start with the sheer scale of the shift. If you look at the global C-section rate, it jumped from just 7% in 1990 to 21% in 2018.
Wow.
Yeah, that is a tripling of the surgical birth rate in under 30 years.
Which is an astronomical change in human behavior.
Oh.
But we have to acknowledge right out of the gate that this is a medical triumph, right?
Oh, absolutely.
This isn't just some random trend.
Not at all. The data from 2000 to 2017 shows that the widespread implementation of modern anesthesia and refined surgical techniques for high-risk pregnancies, it contributed to a massive 38% decrease in maternal mortality.
38%.
Yes. We are talking about saving mothers and infants who in previous centuries simply would not have survived placental complications or fetal distress.
Yeah, a 38% drop is basically a miracle of modern medicine. But skipping the birth canal means skipping some pretty intense physiological triggers.
It does.
I've always thought of it this way, like a C-section is essentially like taking an elevator straight down to the ground floor of a building. It's fast, it's controlled, and it gets you there safely.
I like that analogy.
But a vaginal birth, on the other hand, is like a slow, grueling hike down the side of a mountain.
Very grueling.
Right. The hike is incredibly difficult, but the physical exertion of that hike actually prepares your body for the weather you're going to face at the bottom.
Yeah, that's a really good framing. The hike down the vaginal wall isn't just about getting from point A to point B.
Right.
It is an active biological process involving specific characteristics, intense physical pressure, sudden oxygen changes, and significant temperature shifts. Those factors are the activation codes for vital fetal adaptations.
So walk me through what actually happens during that physical squeeze. Like, what systems are booting up?
We'll take the temperature shift, for example. During a vaginal delivery, the fetus is slowly and progressively exposed to the much colder environment outside the mother's body.
Right. The real world is cold.
Exactly. That slow exposure triggers the release of catecholamines, which are crucial stress hormones.
Okay.
This release controls the blood flow to the infant's skin and induces something called shivering thermogenesis.
Wait, so Shivering isn't just the baby being uncomfortable.
No.
It's like an active mechanism to regulate their own body temperature.
Exactly. It is a survival mechanism kicking online. And alongside the temperature, there are critical hormonal triggers.
Like what?
Well, the intense process of vaginal labor releases maternal hormones that activate the proper reabsorption of fluid in the baby's lungs.
Oh, wow. And if a baby takes the elevator instead of the hike, I imagine that fluid reabsorption just doesn't happen the same way.
It doesn't. When you surgically bypass that hormonal cascade, the fluid often isn't properly cleared from the lungs.
Making it harder to breathe.
Yes, this significantly increases the risk of a condition called transient tachypnea, which presents as a period of rapid, labored breathing in C-section babies right after birth.
That is just fascinating. The sheer mechanics of the delivery physically change how a baby breathes and regulates heat.
It's all connected.
This is Radio EVM.
But if bypassing the birth canal alters something as massive as lung function, what does it do to the bacteria they absorb? Like, how does the microbial journey differ from the physical one?
This is the real crux of the 2023 review. When an infant is born vaginally, they experience a phenomenon known as vertical transmission.
Vertical transmission?
Right. As they move through the birth canal, they are entirely coated in, and they actually ingest the mother's vaginal and rectal microbiome.
So they're essentially getting a starter pack of bacteria straight from the source.
Yes, exactly. And that starter pack heavily colonizes their pristine digestive tract, establishing their very first intestinal flora.
All right.
But with a C-section, the infant is surgically removed directly from the abdomen. That critical vertical transmission is completely bypassed.
So if they aren't getting the mother's vaginal flora, what exactly are they getting? Does a C-section baby basically just swipe bacteria from whatever they touch first in the operating room?
In a sense, yes. Without the overwhelming exposure to the vaginal and rectal flora, the C-section baby's gut microbiome becomes a reflection of the mother's skin microbiome, as well as the hospital environment.
That is wild.
We see a stark, undeniable divergence in what actually sets up camp in their digestive system.
Let's get specific about this divergence, because we said we'd list these out. What exactly is growing in the vaginally delivered gut versus the C-section gut?
Okay, so in the vaginally delivered infants, we see a rich, dominant presence of beneficial species. The primary colonizers are Bifidobacterium, Lactobacillus, and Bacteroides.
Okay.
These are highly specialized bacteria that have evolved to thrive in the human gut, and they perform incredibly complex metabolic tasks.
And the infants who took the elevator,
Yep.
the C-section babies.
Their flora looks completely different. They show a much higher colonization of bacteria typically found on human skin or in clinical environments.
Like what?
We see elevated levels of Staphylococcus, Streptococcus, Corynebacterium, Enterococcus, Klebsiella, and Firmicutes, specifically the Clostridium species.
Wait, Staphylococcus and Streptococcus? Like the bacteria responsible for staph infections and strep throat.
Yes, those species.
Those are the dominant strains taking over a newborn's stomach.
What's fascinating here is how tenacious those skin bacteria actually are.
Really?
Yeah. You might assume that after a few weeks at home, eating and interacting with the world, the baby's environment would balance everything out and correct the gut flora.
That's what I would think, just from crawling around on the rug.
Right. But the researchers analyzed pooled data from babies at 3 to 6 months of age, and the differences were remarkably persistent.
Wait, months later, and the gut still hasn't corrected itself.
Not at all. At 3 to 6 months, the C-section babies still demonstrated significantly higher levels of Clostridium.
Wow.
They showed a colonization rate of 32.9 compared to just 18.2 in the vaginally delivered group.
That's a huge gap.
It is. And conversely, their levels of beneficial bacteroids were severely suppressed, sitting at 14 compared to 23.1 in the vaginal group.
Okay, so essentially, a C-section baby's gut flora looks more like the surface of an elbow than a functional digestive tract.
That's one way to put it, yeah.
But let's push on that. So what if there are skin bacteria in the stomach? What is the actual biological mechanism that makes this dangerous?
To understand the danger, we have to look at what the beneficial bacteria are supposed to be doing during those early months. Let's focus on Bifidobacterium, which is critically deficient in C-section infants.
Okay.
The data emphasizes that Bifidobacterium is absolutely essential for the physical development of intestinal epithelial cells.
What exactly do those epithelial cells do in a newborn? Like, why do they matter?
They form the critical lining of the entire gut. Their job is to manage digestive and absorptive functions, and they also form the barrier that interacts with the immune system.
Oh, I see.
When an infant lacks Bifidobacterium, the actual physical development of that vital intestinal epithelium is stunted.
Ah, okay. So if the epithelial cells are like the bouncers at the club of your bloodstream, letting the good nutrients in and keeping the pathogens out, well,
Right.
a lack of Bifidobacterium means you essentially have untrained bouncers guarding the door.
That is a perfect way to visualize it. And because the barrier is stunted, the implications ripple outward. A compromised epithelial lining directly impairs nutrient absorption and deeply disrupts immune function.
So what does this all mean? If we track this causality from skipping the birth canal to missing Bifidobacterium to developing a stunted epithelial lining, what are the long-term health consequences for these children?
This is Radio EVM.
If we connect this to the bigger picture, an altered microbiome effectively changes a child's entire physiological trajectory.
Right.
The researchers pooled the secondary health outcomes across all these studies, and the associations are striking. For children born via C-section, there is a significantly higher risk of obesity,
Wow.
specifically with a pooled odds ratio of 1.35.
An odds ratio of 1.35. So that means they're roughly 35% more likely to develop obesity compared to vaginally born children.
Correct. And we also see a higher risk for asthma with a pooled odds ratio of 1.23 and an increased risk of respiratory tract infections at 1.30.
That's a lot of elevated risk.
It doesn't stop there.
Yeah.
The pooled data further links this microbiome divergence to higher instances of type 1 diabetes, food allergies, celiac disease, and allergic rhinitis.
Let's connect those dots. How does a stunted gut lining lead to something like asthma, which is a respiratory issue?
It comes back to the immune system.
Yeah.
Your gut microbiome is in constant communication with your immune cells.
Okay.
When the intestinal lining is stunted and lacks the proper beneficial bacteria to regulate it, the immune system can become dysregulated and hypersensitive.
It's on high alert.
Exactly.
Yeah.
That hypersensitivity doesn't just stay in the gut, it manifests as systemic inflammation or hyperreactive airways, which we diagnose as asthma or allergic rhinitis.
That is incredibly sobering. And it's not just about missing the beneficial bacteria, is it? It's also the fact that they have a surplus of skin bacteria causing active harm.
Yes, it is a dual threat. The review highlights that an imbalance of the Clostridium species, which includes C. diff, a common resident of skin flora, can actively trigger infantile gastroenteritis.
So they get hit from both sides.
Exactly. The presence of the bad guys causes acute issues, while the absence of the good guys causes long-term metabolic issues.
And the vaginal group just doesn't face this dual threat.
Quite the opposite. The vaginally delivered babies, armed with robust populations of Bacteroides and Lactobacillus, demonstrated significantly higher levels of carbohydrate and vitamin metabolism.
So they process nutrients better.
Yes. The data positions this enhanced metabolic function as an active protective factor, shielding those infants against conditions like milk allergies and childhood obesity.
Man, when you lay it all out like that, it feels incredibly heavy. A single surgical decision which, as we established, is often a necessary life-saving intervention, inadvertently alters an infant's metabolic and immune destiny.
It is heavy.
I have to ask, though, how solid is the ground we're standing on here? Are the researchers absolutely certain about these sweeping conclusions?
The researchers were acutely aware of the weight of their findings, which is why their methodology was so ruthless. They started their review by looking at 126 different studies on the topic.
Okay.
But they subjected those studies to a rigorous critical appraisal, entirely discarding anything that didn't meet strict methodological standards.
So they aggressively filtered the noise. What were they left with?
Out of 126 studies, they narrowed it down to just 4 highly reliable, high-quality articles, specifically 3 systematic reviews and 1 retrospective cohort study.
I mean, 4 articles sounds like a pretty small pool to draw such massive conclusions from.
It sounds small until you look at what those 4 articles actually contain. Those specific reviews pooled data from 123 original high-quality studies conducted globally spanning Europe, Asia, North America, and Australia.
Oh, wow.
And the sample sizes they analyzed ranged from small cohorts of 7 infants all the way up to staggering population reviews involving over 2.5 million participants.
Over 2.5 million participants.
Yeah.
You can't really argue with a sample size that massive. The statistical power there is undeniable.
It is undeniable, but, it's not without its blind spots. The researchers were very transparent about a crucial technological limitation in the current science.
Oh,
Specifically regarding how we identify these bacteria, the studies heavily relied on a technology called 16S RNA gene sequencing.
here's where it gets really interesting. I love when the science bumps up against the limits of its own tools.
Yeah.
What is the blind spot with 16S sequencing?
Well, 16S RNA gene sequencing is the standard workhorse for analyzing microbiomes. It is fantastic at identifying the presence of bacteria down to the genus and species level.
Okay.
For example, it can clearly tell you if an E. coli bacterium is present in an infant's stool sample, but its resolution stops there. It cannot distinguish between different strains of the same species.
So it can tell me the species is E. coli, but it can't tell me what that E. coli is actually capable of doing.
Precisely.
Let me try to visualize this. It's like having a satellite image of a highway. The satellite is sharp enough to tell you that a specific vehicle is a cargo truck.
Right.
That's the genus and species. But the satellite cannot look inside the trailer to tell you if the truck is delivering fresh produce or if it's hauling toxic waste.
That is exactly the limitation. The 16S method confirms the presence of the E. coli truck, but it cannot differentiate between a completely harmless, non-pathogenic strain of E. coli and a highly dangerous Shiga toxin-producing strain.
Which means we are still painting with a pretty broad brush here. We know the C-section babies have more Staphylococcus and Clostridium. We see those trucks on the highway. But we might not know exactly how hostile or toxic those specific strains are to the infant's gut.
This raises an important question for the future of microbiome science. The researchers openly acknowledge this limitation and point directly to the need for future studies utilizing more advanced, high-resolution sequencing technologies.
We need better tools.
We do. We need tools that drill down past the species level to the exact strain, mapping the precise pathogenic potential of the bacteria colonizing these infants.
So, to bring this all back down to earth for you listening, why does any of this matter to you? I mean, if you aren't a microbiologist sequencing RNA, why should you care about the ratio of Bacteroides to Clostridium in a newborn's gut?
Good question.
I think it fundamentally comes down to informed decision-making.
It absolutely does. For expectant parents who are facing the choice of an elective C-section, having this knowledge ensures you understand the complete biological scope of that decision.
Right.
You aren't just choosing a convenient date on the calendar. You are actively choosing a different path for microbial inheritance.
And for parents who don't have a choice, who need a C-section to save a life, knowing this isn't meant to cause panic, it actually provides an incredible silver lining, doesn't it?
It does, because biological destiny is not permanently locked in at the moment of birth.
Thank goodness.
Right. By clearly identifying that C-section babies represent a high-risk group for specific immune and metabolic conditions, we open the door for proactive, rather than reactive, medicine.
We know exactly what they are missing, so we know exactly what to watch out for.
Precisely. It paves the way for targeted early screening by pediatricians, and looking slightly into the future, it offers the profound potential for customized interventions.
Like what kind of interventions?
Instead of just administering a generic over-the-counter probiotic, imagine a clinical protocol where we administer customized probiotics designed to systematically replace the exact bacterial species, like Bifidobacterium, that the C-section infant missed.
We can actively rebuild the bouncers at the door. We can repair that stunted intestinal epithelial wall before secondary risks like asthma or obesity ever have a chance to take root.
Exactly.
We can essentially supply the gear they missed by taking the elevator instead of the hike.
It is a highly optimistic avenue for pediatric medicine. We are learning how to manually construct the ecosystem that nature usually provides.
That is incredibly hopeful. But as we wrap up today's deep dive, I'm going to leave you listening with one final provocative thought to mull over.
Always a good idea.
It's something the researchers highlighted as a crucial area for future exploration. They noted a desperate need to study maternal confounding variables.
Nice.
Factors like the mother's diet, her own gastrointestinal disorders, or her use of antibiotics during pregnancy.
It adds an entirely new layer of complexity to the vertical transmission process.
Think about the implications of that for a second. If a baby's foundational microbiome is essentially a carbon copy of the mother's flora at the exact moment of birth, how much of our long-term health, our adult metabolism, our lifelong allergies, is actually determined by what our mothers were eating or the medicines they were prescribed months before we even took our first breath outside the womb?
It suggests an intergenerational chain of metabolic health that is far more delicate and far more connected than we ever realized. The choices made during pregnancy literally become the architecture of the child's immune system.
So the next time you see someone frantically painting a nursery or stressing over the perfect unscented baby detergent, remember that the most vital, permanent environment they are building for that child is entirely invisible to the naked eye. Thank you so much for joining us on this deep dive, and keep questioning the hidden systems that shape our lives.
This is Radio EBM.